Welcome to this video. So in this lesson, we are going to be looking at questions on descriptive statistics. Okay, so I'm getting these questions from tutorial sheet 7 for those who are doing A-levels at University of Lusaka. Right, so this tutorial sheet has about 4 or 5 questions. How many questions? It has 6 questions. Okay, nice. So we're going to go over each and every question that you can see here. Okay, so we start from question 1. So question 1, they're saying, consider each of the following variables. Okay, for each one, state whether it is quantitative or qualitative. State whether it is, state whether the quantitative ones are continuous or discrete. State what type of scale the continuous ones are measured on. And then lastly, state the qualitative ones, okay, are nominal or ordinal. Okay, so before we even state anything here, okay, we have to understand these terms here that they are mentioning. Okay, so the first one, they're saying quantitative. Okay, there's quantitative, and then I also saw qualitative somewhere there. Okay, so what do they mean when they say a variable is quantitative? And what do they mean when they say a variable is qualitative? Okay, so when they say a variable is quantitative, they mean that variable, okay, takes on numeric values. Okay, it takes on numeric values. In short, it takes on numbers. It deals with numbers. There should be a number there. Then we are going to call that as a quantitative. Okay, and then qualitative, it will just be a variable that will be describing something. Okay, it will just be describing the state of something, and there will be no numeric value attached. Okay, numeric. Okay, no numeric value attached. Where am I writing number? Numeric. Okay, there will be no numeric value attached to just be a variable that will be describing the state of something. Okay, so a good example here of a qualitative variable is gender. Okay, so you are either male or you are female. Okay, there's no numeric value that is required to describe if you are female or you are what? You're male. All right, and then we said quantitative takes on numeric values, right? So for example, e.g., we can say age. Okay, when they ask you, how old are you? You say maybe, okay, I'm 24, 16 years old. Okay, so there will be a number somewhere there. We're going to call that variable as a what? A quantitative. Okay, so now this qualitative here, okay, the qualitative variable is divided into nominal, okay, and what we call as ordinal. So nominal, okay, when they say a variable is nominal, they mean that that variable, okay, can can be categorized. Okay, that variable can be categorized, but it cannot be ranked. It has no specific order in which it must flow. Okay, it can be categorized, but it can't be what? It can't be ranked. So for example, color. Okay, when we talk of color, when you say blue, green, red, brown, white, whatever color that you're thinking of, there is no color that is above the other. Okay, we can't say red is greater than blue. No, okay, it does not work like that. So that's what it means to be nominal variable. Okay, you can, it can be categorized but not ranked. Okay, we can say, okay, these girls are wearing red shirts. These ones are wearing blue, and then we'll be able to differentiate between them. But it doesn't mean that uh, if someone is wearing red, then they'll be above the one that is wearing blue. No, okay? Just used to categorize, but no rank involved. And then when we talk about ordinal, okay, ordinal will categorized in a meaningful order. So it means here, okay, there will be rank. Okay, that will be taken note. So for example, okay, your education level. Okay, we all know that a degree is better than a diploma. Okay, we also know that a diploma is better than a grade 12 certificate. Okay, so when you talk about educational levels, okay, the variable that will describe the educational levels, we are going to call it as ordinal. Why? Because it's showing a rank there, a hierarchy. Okay, we are saying we are going to say grade 12 is lower than the diploma, diploma is lower than the degree is lower than the master's is lower than the PhD. Okay, so that's how we're going to describe it. So ordinal variable, it will categorize and it will show the hierarchy of something. Okay, so I'm done with qualitative. Quantitative. When I go to quantitative, this can be divided into continuous variables. Okay, and then we also have what? Discrete. Right, so discrete, okay, you guys who are in semester 1, when you go to semester 2, it's a whole topic, discrete random variables. You're going to learn about it. You're also going to learn about it, continuously random variables, okay? So discrete simply means this variable, okay, takes on values that are countable. Okay, you can count the variables. Okay, you can count the variables. Takes on variables that are what? Countable. And then when we say continuous, okay, it will mean the values that this variable takes on are uncountable. Okay, you can't count them. They are uncountable. Okay, so if they are uncountable, they are going to be put into what we call as an interval. Remember, when we're doing set notation, we said a simple interval just from 0 to 1 here. It has millions of numbers in it there. In short, I can't even say millions of numbers inside that interval. It has uncountable numbers. We can't count the numbers that are between 0 and 1. Okay, so we call this as an interval. So when you're talking about the continuous random variables, okay, we'll be talking about uncountable. Okay, something that is uncountable. It can take any value. It can be 0.1, 0.10, 0. It can be any value, but for the discrete one, it will be increasing in one. It can just be 1, 2, 3, 4, 5, 6. Okay, and it will have somewhere where it will end. Maybe it will end at 15. That's all. But for for the continuous one, it will take on what? An interval. All right, so that's that. And then this continuous one, okay, we can further describe it, okay, as an interval, okay, variable, or we can describe it as a ratio variable. Okay, so this interval and ratio are what we are referring to at here as the type of scale. Okay, the type of scale. So the type of scale, okay, when we say interval, then we're meaning a variable that does not have a true 0 point. Okay, so what do I mean doesn't have a true 0 point? For example, time. When we say the time is 0, 0, 0, okay, does it mean the time is not there? Okay, it doesn't mean like that. It means the time is there, but it's just 0, 0, 0. Okay, so it doesn't have a definite 0 point. Okay, it doesn't have a true 0 point. Another good example is temperature. When we say the temperature today is 0 degrees Celsius, do we mean the temperature is not there? No. Okay, the temperature is there, but it's just what? 0 degrees. Okay, so the interval variable is a variable without a true 0 point. And the good example are temperature and time. Okay, and then when we go to the ratio, this one here, okay, the ratio is a variable that has a true 0 point. Okay, so its 0 point, it's very significant. So for example, distance. Okay, for example, distance. If you say that today I've moved 0 meters, then what does that mean? It means you didn't move at all. You didn't cover any distance. Okay, so the 0 point is true. You didn't move. There's 0 distance there. Okay, you travel 0 meters. Okay, or if we say the weight of something is 0, then it means that thing does not exist. Okay, because there's nothing that has the weight 0. Okay, so the ratio, the 0 point is true. For the interval, the 0 point is not what? True. So now that we've learned all this, okay, let's try to classify these questions that we've been what? We've been given here. Okay, so the first one, they're saying what? They're saying the weight of the baby. Okay, so the weight of the baby, is it quantitative or is it qualitative? Okay, we are going to pick quantitative because it involves a number. Okay, so this is quantitative. So is the weight continuous or discrete? Okay, so the weight is continuous. It can take any value. Okay, so if I come to your class and then I start measuring the height of the members that are in that class, it will just be random, 5.4, 6.5. So it's continuous. It takes any value. Okay. Okay, so we've answered the qualitative part, we've answered the continuous discrete part, and then here they said state what type of scale that the continuous ones are measured on. So the continuous one, the scale, it will be the ratio. Okay, remember we said the weight was an example of the ratio. Okay, and then what else? They're saying state whether the qualitative ones, okay, so this one is not here because this one is the quantitative. So we go to B, answers to the question, what country were you born in? Okay, so how can we categorize the answers to the question, what country were you born in? Okay, we see that that one is just simply qualitative. Okay, because it does not involve any number. Okay, there's no numeric value there. So it is qualitative. Okay, and then state whether the quantitative ones are nominal or ordinal. So here they're saying, what country were you born in? So they're just asking you for the name of the country. Okay, so that is what? Nominal. There's no order there. All right. And then the last one, which is C, they're saying for each member of our class, the total number of appearances for class sessions in a semester. So the number of days we go to class in a semester are countable. We can count them. Okay. So it means that even the number that someone will attend, because most of the students don't attend all the classes. Okay. So the classes that they will attend, we can count them. So first of all, this is dealing with a number. So we're going to say what? Quantitative. Okay, to be quantitative. And then is it continuous or discrete? We're going to say discrete. Okay, so this is the name of our institute. We were inspired by this word. So the the total number of appearances for the class sessions in the semester are going to be classified as discrete. Why? Because they are countable. Okay, you can count them. Okay, and then I think that's all. Okay, maybe we try the nominal and the ordinal. Okay, so the total number of appearances for a class, let's say, is it ordinal or is it nominal? Okay, what would you say? Okay, so you can you can pause the video and then you try. Okay, so it turns out that we can't classify it because it's not continuous. Okay, so we are going to leave it just like that. Okay. All right, so let's move to question 2. So question 2, this one is nice now. At least there's something to solve here. I was bored with the questions on question 1. So they're saying, consider the number of days to maturity of 10 short-term investments below. Okay, so we have these values. Okay, so the first thing is calculate the mean and the standard deviation for the days to maturity data. So if you have a calculator, you can just simply enter this data and then to be able to give you the mean as well as the what? The standard deviation. But here we're going to calculate it manually. So the mean given by this symbol is equals to the summation of all the x values that we've been given there divided by what? N. So N is how many values you've been given. All right, so the summation there, we're just going to say 74 plus 80 plus 85 plus That means plus 65, plus 85, plus 95, plus 72, plus 76, plus 72, plus 93, plus 94. Then we divide all this by how many they are, which is 10. Okay, so let me punch this now onto my calculator and see what I'm going to get. All right, so when I punch this, I'm getting 80.6. Okay, so this one here will be my mean. So X bar is just 80.6, which also represented as the expected value of what? Of X, like that. Okay, so that is the mean. And then the standard deviation, okay, we know that the standard deviation is just the square root of the variance. So standard deviation is equals to the square root of the variance. So for non-grouped data like this one, the variance is given as the summation of all x minus the mean squared divided by n minus 1. Okay, so this is the sample standard what? Deviation. So what this means is that we are going to be summing the difference, okay, the squared differences of a value here and the mean, and then we square it, just like that. So this is going to be the square root of, okay, so I'll start with the first one, 74 minus the mean, which is 80.6, and then we say squared plus 80 minus 80.6 squared. So we go on and on until we reach the last one here. So the last one will be 94 minus 80.6 squared. And then down there, we're going to have 10 minus 1. Okay, so I'll punch these now onto the calculator. All these squared differences. Okay, so pam 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 pam. Okay, so the squared differences are giving me 019.2 divided by 9. Okay, so this will be equals to, if I divide this, I'm getting 133.4. So it means our standard deviation will be equals to the square root of this number, which is about 10.63. So I found my standard what? Deviation. Okay, found my standard deviation. And then now we can look at the next question. Okay, so the next question now. Okay, so the next question, they're saying make a stem and leaf plot for the days to maturity data. Okay, so a stem and a leaf plot is in this form. We are going to have a stem here, and then you are going to have a what? A leaf here. So the first thing that I advise my students to do is just to arrange the data that you have here in order. Okay, just arrange the data that you have there in order. So the lowest we can see here is 65. Okay, and then there's 72 and another 72. And then I go to 74, 76. Okay, I'm done with the 70s. I can see 80 and then 85, and then 93, 94, and then 95. So I've organized this data in order. Okay, so now I can put it in a stem and leaf plot. But let me draw it a bit nicer. Let me get some Karula here. So we have this like that. Okay, nice. So we are saying this is the stem and then this is the leaf. Okay, so the leaf is always one digit. So there are situations where we're given three numbers, like the one which was on your test. Okay, like 200, maybe one, and then 207. Okay, so the leaf is always one digit, but this stem here, it can be two. So in this case, if you have three, these two here are going to be your stem, and then the last one is going to be the leaf. Okay, but in this case, we only have two. So one will be the leaf, one will be the what? The stem. So for the 60, for the 60s, we only have six, and then the leaf will be 5. So this is 65. Then for the 70s, we have 72, another 72, 74, and then 76. For the 80s, I have 0, which is 80, 85. That's all. For the 90s, I have 3, 4, and then 5. Okay, so this is my stem and leaf plot. All right, and then question C, this one here, they're saying hence or otherwise compute the interquartile range. So now the interquartile range is equals to, okay, Q3 minus Q1. So Q3, it's like the median of the upper half of the data, and then Q1 is the median, okay, or the middle value of the what? Of the lower half of the data. Okay, so we can easily find Q1, we can easily find Q2, okay? So we're going to use a special technique here. Okay, so I was saying we are going to use a spatial technique, okay? So this data here, I've organized it in order, okay? So for me to find the Q3 and the Q1, I first have to find the Q2. So the Q2 is just the median of the data. So how do I find the median? Okay, I'll just use the cancellation technique. So I'll cancel this one, 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 cancel this one. So I remain with two of them in the middle. Okay, I remain with a 76 and a 80 there. So it means, okay, what this means is that between 76 and 80 here, I'm going to have my Q2. So if you want to find this value, just say 76 plus 80 divided by 2. Okay, so that will give us what? If we are to find the exact value of Q2. Okay, that will be 76 plus 80 and then divided by 2, that will be 78. Okay, so somewhere here between 76 and 70 and 80, you're going to find your Q2, which is 78. Okay, but our interest is not finding Q2, but it will help us find our Q3 and our Q what? Our Q1. Okay, so this means that this Q2 has divided this data into the lower half and the upper half. Okay, so the middle value of the lower half is the Q1. The middle value of the upper half is the what? Is the Q3. Okay, so now I'm going to use green to start canceling out here. So I'll start from here. I cancel out this one, cancel out that one, cancel out this one, cancel out that one. I only remain with the 72. So it means my Q1 is 72. And then I go to the upper half, I cancel 80, I cancel 95, cancel 85, cancel 94, I remain with the 93. So it means Q3 is equals to what? 93. So this will mean that interquartile range will just be equals to 93 minus 70 what? 2. So 93 minus 72 is going to give me 21. Okay, so 21 is my interquartile what? Range. Okay, so that's my interquartile range. And then what other questions are they asking here now? Okay, so they're saying, are there any outliers in this data? Okay, so how do you know that a value is an outlier? Okay, so first of all, you have to know the range of accepted values. So accepted values here is equals to accepted values, okay, is equals to Q1 minus 1.5 multiplied by the interquartile range, and then the upper value to be Q3 plus 1.5 interquartile range. Okay, so let's find the range of accepted values. So this one to be 72 minus 1.5 multiplied by 21, comma, 93 plus 1.5 multiplied by 21. So this is what I have here. Okay, so 72 minus 1.5 multiplied by 21. Okay, I'm getting what? Okay, let me multiply this. Okay, so it's 72 minus 1.5 multiplied by 21. Okay, so I'm getting 40.5, comma, and then up there, it's 93 plus 1.5 multiplied by 21. So I'm getting 124.5. Okay, so this is the range of accepted what values. Okay, this is the range of accepted values. Okay, so now you go back to your data here, you check, okay, is there any value in this data that is below this smallest number, okay? Or is there any value in this data that is above this biggest number, okay? If you can find a value on the data that you've been given that is below the 40 or above the 24.5, then you are going to call that value as an outlier, okay? It's way below or it's way high. Okay, but in this case, okay, in this case, we see that all these values here are between 40.5 and 124.5. So we are going to say D, we have no outliers. Okay, there are no outliers, and we justify that by calculating this range of accepted what values. Right, so thank you so much for watching this video. Okay, if you'd like to access the full video where I was solving all the questions in this tutorial sheet, you are very much welcome to register on our website. Okay, so our website, we have videos on all the tutorial sheets, okay, from tutorial sheet 1 up to tutorial sheet 8. Okay, and videos for test 1, test 2, as well as the mid-semester exams. Okay, so when you come here, you can open the math folder, you go to general mathematics. Okay, that tutorial sheet is for UNILUS. You can go to tutorial sheet first of all, and then you go to UNILUS. Okay, you go to first semester. Um, you go to the video solutions. If you want, you can check the written solutions. They are there. So video solutions, you're going to find these folders here. So here they are tutorial sheet 1 videos, 2, 3, 4, 5, up to 8. Okay, so feel free to register with us and revise easily for your tests. Okay, so thank you so much for watching and have a great day.